Hello my esteemed viewers, welcome once more to my channel. On this particular lecture series I'm going to consider some few examples under vectors, how to handle problems under vectors. If you are given two vectors, how do you multiply them? Remember in my previous series we mentioned about multiplication of vectors using either cross product or scalar product. So this particular example, we're going to look at vector product of two vectors and also see how we can calculate the angle between two different vectors. So I have on my screen electromagnetic Poynting vector n. So it's a vector n, which denotes the direction and transfer rate of energy due to electromagnetic field in space. Can be expressed using this relation n equal to E cross H. E and H represent the electric and magnetic fields respectively. We're given the expression for E and that of H. We're expected to find the cross product between them, which gives us the value of n. Now to do that, we simply apply the matrix notation, that is finding the determinant of a matrix. We're going to consider these two quantities as we are going to consider these two quantities in matrix form, E and H. So I can say that, let's take the solution. Now E cross H, zooming on to find the determinants, gives us n, which can be expressed as this. This is I, J, and K, unit vectors along the x, y, and z axis. You come to E, unit vector along the x axis is 5, along the J is 2, and along the z axis is 6. Then for H, unit vector along the x axis is 7, along the y axis is 6, and along the z axis is 5. Having done this, let's remember that there are signs attached to every column in this determinant box. You have the positive sign here, negative sign, and positive sign. These signs must be taken into consideration when solving for the determinant of this matrix. So we can proceed by saying E cross H is equal to, you take this first unit vector I as a multiplier. If you are using the first unit vector as a multiplier, you have to block that entire column. So you open a bracket and multiply diagonally the other two columns. So we say 2 times 5. We subtract the next column from it, minus 6 times 6. This is for the I as a unit vector. We are done with I, so we can open that column and move on to J. Moving on to J, remember this negative sign on top of this column, so we say minus J into. Taking J as a multiplier will cause you to block the entire column of J. So you multiply diagonally the other two columns, that is I and K. So we have 5 times 5 minus 7 times 6. That is for j. Then plus k into, because this is positive, we release or we open this column and move on to k. Since we are using k as the multiplier, we are going to block this k column, and so we have the remaining two columns, 5 times 6. So we say k into 5 times 6 minus 7 times 2. This is for k. So we proceed by evaluating what we have in the bracket. So we say n is equal to I into 5 times 2 is 10. Bring that here. 6 times 6 is 36. So 10 minus 36, close the bracket, minus j into 5 times 5 is 25 minus 7 times 6 is 42. So we say 42 plus k into 5 times 6 is 30 and 7 times 2 is 14. So 30 minus 14, we close the bracket. So this leaves us with n is equal to I into 10 minus 36 is minus 26 then minus j into 25 minus 42 gives us minus 17 plus k. 30 minus 14 is 16, so we say 16k. This is saying n equal to minus 26i. Minus times minus gives us positive, so we say plus 17j plus 16k. So this is the value for n. This is the value for n. Assuming we are asked to find the magnitude of n, for example, then we move further to use Pythagoras rule to find the value of n. We shall address that in the next problem. We have a second problem here. A proton with charge Q moves in a uniform magnetic field B equal to 1.2k Tesla with velocity coordinates given as V equal to 2I plus 3j plus k times 10 raised to the power 3 meter per second. It's acted upon by a force according to the relation F equal to Q in bracket V cross B. Calculate the force acting on this proton. How do we do this? It's just simply cross product. So we take our solution. First and foremost, we are going to evaluate the term inside the brackets. F is given as Q into V cross B. We'll evaluate what is inside the bracket first before we proceed to multiply by Q, which is like a scalar here. So this is like using a scalar to multiply a vector, or let's say a scalar to multiply the cross product of a vector. So we say V cross B is equal to, we use determinant method also, this is I, J, and K. For V, we have 2 representing the unit vector along the x-axis, 3 is representing the unit vector along the y-axis, y1 is representing the unit vector along the z-axis. For B, which is the magnetic field, we only have the unit vector along the z-axis. So that implies that for the x and y-axis respectively, their unit vectors are 0. So we say 0, 0, and 1.2. Remember to include our signs here, positive, negative, and positive. And of course, we are told that V is this times 10 to the power 3, so we include that here. Going further, we say V cross B will be equal to I into, just like we did previously, we block this column and multiply diagonally. So it will be 3 times 1.2 minus 0 times 1. Close this, minus j into, if you are using j, then you release I and you block that of j. So you exclude j and multiply the other 2 columns diagonally. So you have 2 times 1.2 minus 0 times 1. This is what we mean, 0 times 1. Plus k into, we are now using k as our multiplier, so we release the other columns and block that of k. This is 3, this is 0. So we block this column and multiply diagonally. That gives us 2 times 0 minus 0 times 3. We are left with V cross B is equal to, and of course everything here is times 10 to the power 3 meter per second. 3 times 1.2 gives us 3.6. This is 0, so we say 3.6i, or 3.6 minus 0 into I, minus j into 2 times 1.2 gives us 2.4. This is already 0. We say 2.4 minus 0. Plus k into 0 minus 0. Times 10 to the power 3 meter per second. So this gives us V cross B is equal to 3.6i minus 2.4j. K has nothing, so which is 0. So we say 3.6i minus 2.4j bracket times 10 raised to the power 3 meter per second. Therefore, our force F is what? Q into V cross B. And we were given the value for Q as 1.6 times 10 to the power minus 19. So our F will be equal to Q, which is this 1.6 times 10 to the power of minus 19 colon into V cross B, which is 3.6I minus 2.4J times 10 raised to the power 3 meter per second. As you can see, this is a scalar and this is also a scalar. So we can multiply both of them so that our F finally gives us 1.6 times 10 raised to the power minus 16 into 3.6I minus 2.4J, all in Newton. So this is the force acting on the proton. So let's consider one more problem. So assuming I have a vector A, let's say if A represents a vector given as 7I plus 2J plus K, and another vector B is represented by 2I plus 2J plus 3K. Find the angle between A and B. Now, this can actually be handled by both vector product and cross product. So we'll consider that of vector product. Then when we come to lecture series addressing dot product, then we are going to handle this. Again, we can find the angle between two vectors using either the cross or vector product, or we can use the dot product. Here we'll consider only the cross product. In the next lecture series, we're going to look at how to find the angle using the dot product. You will still arrive at the same answer, regardless the route taken. So first and foremost, how do we handle this situation? We have to know the exact formula to apply. The exact formula gives you a direction on what to do. So first and foremost, A cross B. A cross B is expressed as the magnitude of A times the magnitude of B sine theta. So if that is the case, then sine theta gives us the magnitude of A cross B all over the magnitude of A times the magnitude of B. I can just express it this way. So first and foremost, we're going to find the magnitude of A and B respectively. So the magnitude of A is expressed as this. You use Pythagoras rule. 7 squared plus 2 squared plus 1 squared. That gives us the square root of 54, which is approximated to 7.35 units. So 3 significant figures. Then that of B is equal to 2 squared plus 2 squared plus 3 squared is equal to the square root of 4 plus 4 plus 9 . That gives us 4.12 units. Then we move ahead to find A cross B. Which is equal to, we use the matrix form. This is I, J, and K. We have 7, 2, 1, 2, 2, 3. Always remember the sign notation. So A cross B, just like we did in the previous examples. A cross B gives us I into 7 times 2 if you are using I as the multiplier, you have to block that I column. So blocking the column, we have J and K remaining, so we say 2 times 3 minus 2 times 1. This is for I, minus J into, of course by now you should be conversant with how to do this. So minus J into 7 times 3 minus 2 times 1. Plus K into 7 times 2 minus 2 times 2. So A cross B gives us I into 3 times 2 is 6, 2 times 1 is 4, so 6 minus 4, minus J into 7 times 3 is 21, 2 times 1 is 2, plus K into 14 minus 4. This gives us 6 minus 4 is 2. Sorry, 6 minus, this is 2, sorry. 2 times 1 is 2, please. This is 2. So 6 minus 2 will give you 4i. Minus 21 minus 2 is 19. So minus 19j plus 10k. Now we move to find the magnitude of A cross B. So the magnitude of A cross B will be equal to 4 squared plus minus 19 squared plus 10 squared. That gives us 477, which eventually gives us 21.84 units. So our sine theta is equal to A cross B, magnitude of A cross B, all over the magnitude of A times the magnitude of B. This gives us 21.84 all over 7.35 times 4.12. This is 21.84 all over 30.282. If you evaluate further, sine theta gives us 0.7212. So your theta will be the sine inverse of 0.7212, which leaves us with an angle of 46.15 degrees. So that theta approximately is 46.2 degrees. This answer is to 3 significant figures, or just say 1 decimal place. So this is how we can find the angle between two vectors using the vector product. Like I said earlier, in the next lecture series, we're going to look at the dot product between two vectors and how to use that same dot product to calculate the angle between two vectors. Once again, remember to like my channel, subscribe to my channel for more notifications. Thank you.